about the warm-ups. So did you guys use your calculators to do the warm-ups?
Yeah. I mean, no, not for the first two.
Well, and I'm okay with that. But if you grabbed your calculator, I'm a little disappointed. But you can, it's fine. Because it did say evaluate, which means calculate, but did I give you ones that you guys should have been able to do without your calculator for warm-up 1 and warm-up 2? Yes. But again, it's fine. So with the warm-up 1, did you get 5 for both?
Yes.
So this is the product law, which again is on your guys' formula sheet. If you have logs that are being added together that have the same base, that is key. Because if you have a base 2 log and a base 3 log, you can't put those together if you're adding them. Okay, they have to have the same base. So these are both base 2. So if you're adding logs, you can put the arguments together, and you can simplify it to one log. In this situation with the base 2, and what do you do to the arguments? You can multiply them. So addition means multiplication when you're using your log law, your product log law. Again, these are on your formula sheet, but you probably won't need your formula sheet because you'll use them so much. So addition, same bases, you can put them together by multiplying the arguments. So with the warm-up 2, did you guys both get 1s?
Yeah.
So key thing here, when you're subtracting logs, right, with the same base, that means you can put them together, the arguments together, but they will be, instead of multiplication, it'll be division. Okay. So we can use these laws to help us simplify. Okay, just like if I have a 2x plus 3x, you guys have been working with polynomials so long, you know how to put those together. Okay, now I'm going to show you guys how to put logs together. So I'm not going to go to warm up 3 yet. So let's just use these laws with some just basic examples. Right, so these are on your formula sheet. I think they use M and N, but again, does the variables matter? No, right? If you look at, does anybody have their formula sheet out? Does it use M and N? Yeah. I think I would have probably tried to take how it's written on your formula sheet, but again, it doesn't matter what variables. All right, so for example 1, it says express each of the following as a single logarithm, then evaluate. So those are the instructions. So I kept them really basic. So you can see here that they're both log base 2s. So that allows you or tells you that you can put them together. So the operation in between them is subtraction. So since it's subtraction, we know we can put them together and it become 1 log base 2. But what are we going to do with the 2 arguments? Divide them. So of course, guys, I don't need you to show me this step, but these are the notes, so I'm going to show every piece. Because can you just divide them and write that number down? Yeah. But again, I want to show all my work. So log base 2, so if you go 96 divided by 3, that's going to give you 32. So this now, since they're all numbers, we can evaluate that. So 2 to the exponent of what gives me 32? Yeah, we just did it above, right? So that one, hopefully, we're good. So this right here, guys, answers the first question, right? So the single logarithm, right, that it asks for in the instructions is this piece. Then the second part of the question asked us to evaluate, right? So we did the single logarithm. The evaluate part of the answer, obviously, is that piece. So there's 2 things being asked in this question. Please understand the difference. So are you guys going to freak out if I give you pluses and minuses?
No.
No, you still do the same thing, right? So are they all base 3s?
Yeah.
So then we just go log base 3. We're going to break it all the way down to 1. And then bracket. The 27 is going to be on top. The 2 is going to go to the bottom. Oopsie. And guess where the 6 is going to go? So it's a plus, so it should go on top. So you could do it separately, because don't write this down, but could you guys do this? Just so you guys can see why I can keep going and not have to do it twice. Could you evaluate that and then do a multiplication again after that? So instead of doing it in 2 steps, you just have to realize that if all the pluses go on the top and it all becomes multiplication, whatever goes on top, and anything behind a minus sign goes to the bottom. And if there's more than one thing that goes to the bottom, they get multiplied. So I don't want to do this in 2 steps. But hopefully that gave you the visual of why that can go on the top. So if I simplify that, that's going to be log base 3. So that's 321, 681. No, so 321, 6, yeah, it's 81. All right, so it's 27 times 6 divided by 2 is 81. So that is our single logarithm. And that's going to equal 4. And then you're done. Okay, so 2 parts. First part, there's your single logarithm, and there's you evaluating it. So do you see how maybe our logs are going to become very useful? Right, they're actually very useful. So right now we're using them to simplify things, but do you guys see how we could maybe use them to expand things as well? Yes, so we'll use them both ways, okay? I would say probably 80% of the time we're using them to break it down smaller, but you will have questions where you have to start maybe at the log base 2 of 32 and come up with expressions that would be equivalent, expanding it. Okay. All right, so go ahead. This one has log base 6, so go ahead and do this one now. If you haven't already, I will do it, but if you have already, just wait. I'll do it as well. So anything that has a plus stays on top. Anything that's a minus goes on the bottom because it's division. So log base 6 of 36, which is 2. Questions, guys, with that one? And like I said, is everybody okay with me doing it in one step like that? Right, so anything after subtraction, because like I said, I could do it each piece to show you guys, right? Like I kind of showed you guys above. But to me, hopefully that's okay. If not, say something to me. So before I do this one, guys, how many numbers are going to be on top? How many numbers are going to be on the bottom? Okay, there's going to be 2 on the top and 2 on the bottom. And they're all base 2, so we're good. So log base 2, we're going to bring it down to a single logarithm. So this is a positive one, so it goes on top. This is a negative one, it goes on the bottom. Positive, negative. So that's going to give me 6 over 48. Which is 1 over 8. Which hopefully all you guys can tell me that evaluates to? Perfect. So hopefully the work that we did, guys, in the last chapter with our exponential functions is now helping you with some of the log stuff, right? Because remember when we had to get our same bases? That's the same idea here. 2 to the exponent of what gives me 8 is 3. So therefore 2 to the exponent of what gives me 1 over 8, which is still a 3, but it has to be a negative. So those are our product law and our quotient law, right, which helps us with our logs when we're adding, subtracting logs that have the same base, right? We can put them together. So this next one, guys, your power law, this is the one I was talking about that I'm like, trust me for now, okay? This is the law that I'm talking about. So here, did you guys get a 668? The reason why I put all 3 up there is, do you guys think sometimes students get mixed up with the second and third one? Do you see the difference of them? So please make sure, guys, when you have an exponent on the argument, that's when it can be brought down in front, okay? So these first 2 are the same. And that's what I was talking about last class. So right here, if I have 3 log 100, this is the same as saying just log base 2 of 100 just equals what? Just this piece right here, 2. But then I can take 2 and times it by 3. That's the understanding behind, without using a calculator, why it's 6. This one, if you didn't know that log law, you would have to literally on your calculator type that in. So this one, I was saying, I agree with you, if you type this one into your calculator, but this is the same thing, right? Log base 10 of a million, right? So this is saying 10 to the exponent of what gives me a million, and that also equals 6. So this is saying the argument is 100 times 100 times 100, right, inside here. When the exponent is on the outside, okay, that is saying log 100 times log 100 times log 100, which is 2 times 2 times 2, which is 8. So if it's on the outside of the brackets, guys, that's the key piece, because do you think you're going to get questions where it's on the outside? You will. If it's on the outside, you can't use your power law. Okay, it doesn't get to go out in front. You have to think about it as that log being multiplied however many times that exponent is. Because I never used to have this in the notes, but then I'd have students mess them up and think they're the same thing. Yeah. About what, sorry? Like how to evaluate it? So A, remember from last class, 3 log 100, like how to evaluate it without a calculator?
Yeah.
This is asking logs mean exponents. So this is saying 10 to the exponent of what equals 100, right? So 10 to the exponent of, for this one, this is just saying 10 to the exponent of what gives me 100? 2. So this piece is 2, and then you're timesing it by 3. So you're kind of in your head changing it to exponential form, right? So logs are another way to think about it as an exponent. Same thing as if I gave you log base 2 of 8. That's asking you 2 to the exponent of what gives me 8? So the answer would be 3. All right. So with this power law, guys, this allows us to evaluate things more simple, because sometimes it's better to have the number in front of the log. Sometimes it's better to have it as an exponent, depending on, okay, the question. So if you're asked to simplify, guys, this is the key part. You cannot use the product and quotient law if you have a number out in front. Make sense? Do you see with your laws that there's 0, what's in front of all the logs? There's a 1. So if you have numbers out in front of the log, you have to use your power law first to get rid of it. Then you can use your product and quotient law to simplify. So let's show you what I mean by that. So do you guys see the problem in this question? What's a problem that we can't go right to the the product and quotient law? That lovely half and that lovely third. So there's basically, you need to get rid of those first before you can go to your product, or in this situation, it's going to be your quotient law because it's subtraction. So remember, your power law goes on the argument. So that's what we would have to do first. So then I would have log base 2 of 16 to the exponent of half minus log base 2 of 8 to the exponent of 1/3. Do you guys think it's a good idea to evaluate those? Yeah, absolutely. If you can evaluate them, if it's nice, then evaluate them. Because you know that exponent half means square root. Exponent of 1/3 means cube root. And if you type them into your calculator, if you forgot that and you ended up with a gross number, then you would leave it as it is. But these ones, I would clean up a little bit before I use my quotient law. So 16 to the exponent of half equals 4 minus log base 2. 8 to the exponent of 1/3 equals 2. And I'm so bad at this, I never read the instructions. So it does want us to break it down to a single logarithm, then evaluate. Because realistically, guys, could you evaluate those really quick, really fast in your head? Yeah. But if you do that first, you skipped breaking it down to a single logarithm first. So that's why I'm not going to just evaluate yet. I'm going to still break it down. So it's subtraction. So log base 2. So subtraction means divide. So then I have log base 2 of 2. There's the single logarithm, which now I can evaluate to a 1. Because 2 to the exponent of what gives me 2? 1. So as I said last class, guys, push yourself to try not using your calculator as much as possible. Any questions, guys, with that? So does it make sense? Any numbers out in front? If you're trying to simplify and break it down to a single logarithm, you have to use the power law first. Always get rid of it. Okay. So with this one, away I go. So this has to go up. This has to go up. So I have log base 10 of 5 squared, which is going to be 25. And then log base 10 of 2 to the exponent of 2, which is going to be 4. So away I go. So this one, it's addition. So instead of dividing, I am multiplying. So when you evaluate that, guys, what do you get? Perfect. Because again, that's when the number's not written there. Remember, it's always a base 10. Okay. So go ahead, finish the last 2, and then I'll do a couple with you in example 3 just to make sure variables don't freak you out. So I love this example because it even further kind of reiterates or shows you guys, right, why when you have an argument of 1, right, y equals 0. Because realistically, if you have an argument of 1, that means you subtracted 2 logs that were exactly the same. Kind of gives you, like I said, a nice visual of what happened. Why did that happen? Because only way that you can get a 1 here, right, exactly, is by dividing 2 numbers that were the same, which means you had 2 logs that were the same. Sorry, I'll get caught up to you guys. Did you guys get 2 for the last one? Did you guys have a calculator for that one?
Just for the 81.
Why? Can you guys do that? push yourself. All right, guys, so they obviously can get more complicated than what I'm showing you guys today. We're going to spend a couple days on log laws. And when I say more complicated, it's just the arguments can get a little bit messier, right? They can be like root 3s or 1 over 81s, right? But the process still stays the same. Yeah. So if the bases were different, you can't use your log laws on them. Yep. So there's no way, because could I give you an expression that maybe you have two bases that are base 2s and then two bases that are base 5s? Yeah, but then you would have a binomial, right? You wouldn't be able to break it all the way down to a single logarithm. Yeah. Yeah, so then you would get 2 terms. Yeah. All right, so with these ones, guys, so here it says express each of the following as a single logarithm. So these ones maybe look scarier, but do you guys do them the same way? Yeah, it's just hence why it doesn't say evaluate in the instructions anymore, because you're going to get a single logarithm in terms of variables, so you're not going to be able to evaluate. So here you still have to get rid of any numbers that are out front. So remember, guys, when you take this 5, you're leaving that negative. It's a minus. So the 5's just going, right? Because sometimes I've seen students take the negative with it. Nope. It's a subtraction. The negative stays. The 5 is going to go up on the E. Right, this half is going to go up on the A. So I'm going to rewrite it without the numbers out in front. So you are going to use some of your grade 10 exponent law knowledge in this question. So we have log. Again, I'm writing every single step down, guys. Because you could go right to simplifying first, but I just want to show you guys the number out front going up. So away I go. They're all base what? They're all base 10, so we're good that way. So then bracket, the B goes on, top, the D goes on, top, the E to the 5 goes to the bottom, the A squared goes to the bottom, and the A to the half goes to the gentleman, top. Are we done? No. Right, so if I start asking you to use your log laws on variable bases, there's a good chance you're going to have bases that are the same inside the brackets that are making up the argument that you have to use your exponent laws. So then this would be the same as, so log base 10, so I have B, D, 1/2 minus 2 is negative 1.5 over E to the 5. Would you guys leave that? Don't leave negative exponents. So instead of leaving the A on top, you're going to move it to the bottom. Am I going over to the other question? I better put it over here. So then I'm going to have log B, D, A to the 1.5, E to the 5. Oopsie, sorry. So again, just moved it to the bottom. Now, would you guys freak out if I wrote it like this? Yep. So no, let's go through log laws. So if I have A to the half over A squared, guys, remember what do we do to our exponents? We minus them, which gives me A to the negative 1.5, right? Okay, so that's where it went. So as I was saying, if I wrote this, do I lose anybody? I haven't finished yet, so let me finish this. Late, guys. Kim. Yeah, a little scary. Are we good? Because you never know, guys, how they're going to write it. So you need to realize 1.5 is what? 3 over 2. 3 over 2 back into its radical form is square root a cubed. So sometimes they might write it here as 3 over 2. You don't have to do this in your final answer, guys. You don't have to. Both of these are equivalent. You just have to realize that if they do write it like this in a final answer in a multiple choice, that you're okay. Yeah, Rusha. On. Oh, yeah. Absolutely. Okay, yep. So Rusha even went further, which is good. So are you guys okay with that? That's what you mean, right? Yeah.
Wait, why?
Thank you for bringing it up, Rusha, because they might do that as well to you guys. So remember, when you guys are simplifying radicals with variables, you guys have to remember that a cubed is the same as a squared times a. That divides out or cancels out, so we're left with right. So yes, that is also an acceptable answer. Okay. So the biggest part, guys, with this log chapter is there's so many different ways to write the same thing that you have to be able to wrap your brain around all the different ways, because you never know. Because one way, I would say this is definitely the most simplest, like this last form here is the simplest form, okay? But all three of them are single logarithms, right? So to me, you would get full credit for all of them. Because realistically, this is simplified as well, because it didn't say you had to change it to radical form, right? So again, all of them are equivalent. I just need you to, if you get to here and that's not written like BD over a to the 1.5, e to the 5th on the bottom, that, and they write it this way in a multiple choice, you still you circle the right one, because you're like, okay, I got here, oh, this is the same thing, or the second one is the same thing. Okay. All right, so go ahead and do example 3 and example 4. I'll give you guys, if you're already doing it, perfect. I'll do it in a second. What I'm going to do, guys, is hand out the little practice on basic log laws to you guys. And I want to hand out early the summative assignments, so some of you maybe handed in better on time this time. Yes. Even though I've handed it out really early every time, it's just thought I would throw that out there. So the 8.3 assignment, guys, is your practice of your log laws. The second one, I'm just getting your summative assignment handed out early. If you get this done, then you can start working on questions from there. So no technical questions, guys. Today just the 8.3 that I've given you, and if you get that done, then you can just start working on any of your review assignments, because you have 2 formative review assignments to do, and you have now your 1 summative. I got let me. Oh, I see. Oh, no, I got it. I got it. What?
No.
We always want. Are you? Okay, who cares? You play the game. Yeah, I know.
Always.
Well, just one's the homework for today, and the other one's just the summative assignment for later. Everybody got two?
I'm missing the. What's? Oh, this one.
Actually, I don't know. No,
It is.
4 to 5. What? How many 6 over 5 is a 6 over 5? What do you get 6 over 5?
Oh wait, we're supposed to do this? Yo, I didn't. What you think you was? Yeah.
Yeah, she uses 100%. No. My -9. 100% brain fat. Brain fat. You know how you apparently use 20%? You use 100%.
Wait, you only have 20% brain power? That's catfish.
You know the movie?
Yeah.
Yeah, that's right.
I don't even know.
I was
Slower than that.
I was
I
just
think it's
preparing
like
for that.
10%.
10%.
Yeah, you can't use.
Wait, I could be smarter than you?
Didn't you take psychology?
No, yeah, I did.
Yeah, I did.
No. They talked about sleeping disorders for like 90% of the time.
You don't
The
use it.
major thing that I got out of that class is narcolepsy. The major thing that I got out of that class is narcolepsy. It's when you like fall asleep. Like you can be driving, but you just yeah, that's why you're not allowed to drive with narcolepsy. Yeah.
You know what? Let me do that. Trust me, so I don't have to pass it. The marks.
Like, what if you're like playing football?
Yeah, but if we
Yeah, that happens. Just fall asleep. Yeah, like it's so weird. What's wrong with that? The first person with narcolepsy. Randomly fall.
It's narcolepsy when you just fall asleep.
What?
Like literally. Like, so I have
Pretend I'm driving. Pretend I'm driving, right?
Oh. I wonder what that person was doing.
No, like other people have it. Other people are weird. Not even that's like
Yes.
Well, is that a disorder?
Yeah.
Oh,
So
shoot.
no, it's a mental disorder.
Oh, not physical. No, I didn't know. Okay, I'm sorry. No, it's fine.
Tourist.
What? Still in this world.
We're still mad at her.
What's 2 times?
It's just the same thing. It's always the bottom of
There's going to be one on OneNote.
Oh.
I don't know if I put it there yet, but I have one.
But is this summative?
No, it's just formative. It's just practice.
I mean, I know I don't remember tracking all this. I'm gonna see if Miss Hall graded me. Wait,
Yeah, it's a thing. You subtract something. It's like 1, 2. Yeah.
what's 768?
No, you always minus 2.
Angela.
No, I mean negative. Because this is.
You do 2 minus 4.
It's 0.8 minus 2.
Miss Calvert, can I borrow a calculator? This one's low battery.
Oh, is that one? That one's yours?
Yeah,
Mine.
this one's
Yeah. So you'll have.
Here, you're welcome.
Just do it.
No, you bring this down.
Pardon?
The very last step.
Yeah.
How is that? Like, isn't that like?
Because it's a fifth root, so the only, not that you have to do that, but remember, if you have a fifth root, the only thing that's going to cancel out a fifth root is another 5, right? So then this can be split up, this one here, to this. So that would be the same thing as the fifth root of p to the 6th. So then this can cancel out just to a p, and then you're left with 1 underneath.
No.
So the index will tell you how many to bring 1 out. So if it's a fifth root, I gotta take 5 of them out to get 1, right? Because it'll cancel. So if it's a square root, all multiples of 2 can come out as a 1.
So for here, you have 4. Instead of like 1, you have 4 flat.
And again, not that you have to do that. Like even on the diploma, they probably would just leave it here. Or even here. Like none of these, like you could stop at this step. It's totally acceptable. It's just, again, in a multiple choice, if that wasn't there, then you gotta go, okay, I know I'm right, which is equivalent kind of idea. Is all.
Yeah, she did, but she put it down. You have a positive. It's supposed to be a negative.
Wait.
And then you put it down.
Sure, you can know.
Hey, thank the ladies.
Thank you. Special like that. It's coming to me. Now that I like explained it to myself, and you explained it again. Those look good.
Wait, you guys come to
Yeah.
Hey,
Whoa.
Oh my god, I'm so woke. You guys see, right?
No.
It's almost there.
just kidding, yes.
Go for it.